Hello friends, welcome to my YouTube channel. My name is Prathamesh. Without wasting our time, let's begin. And if you like, please like, share, and subscribe.
For years, interacting with a large language model on a mobile device has been an isolated, transient event. You ask a question, receive an answer, and the context dissolves. This lack of persistence caps productivity. If the AI cannot retain your morning field research, you cannot build upon it in the afternoon. Mobile AI has historically functioned as a quick reference tool, limited by a total lack of structural memory. On April 30th, 2026, Google changed that structure by integrating Gemini notebooks directly into the Gemini mobile app, now available globally for free users, covering both Android and iOS devices, and expanding access across Europe. The mobile device now functions as a direct ingestion node for a persistent retrieval augmented generation, or RAG, system. By bridging field data collection and persistent notebooks, the system removes the requirement to manually move fragmented notes to a desktop for synthesis. To map the architectural layout of a user ecosystem, mobile devices are on the left, a centralized notebook vault on the right. In the old system, mobile devices ping a cloud model, returning data that cannot be saved. The integrated architecture feeds structured documents from those mobile nodes directly into a centralized vault. This unified cross-platform RAG architecture replaces fragmented mobile searches. The notebook serves as a persistent context window, holding data steady across all hardware platforms. Tracking a single piece of data through this pipeline reveals how the mobile-to-web handoff actually functions. Moving from ephemeral chats to persistent notebooks changes the baseline value of every mobile AI interaction. The process begins at the edge, the initial point of data capture on the mobile device. Phase 1 involves direct file integration at the source. Users can upload documents and PDFs into a specific notebook from within the mobile app. You no longer need to be at a desktop environment to initialize a structured knowledge base. Phase 2, Chat as Context, handles natively generated text. An active, transient Gemini conversation can be migrated directly into a static notebook. This converts a transient query into foundational context. These saved chats are then available as source material for completely separate future tasks. Subsequent AI outputs are tailored specifically to these edge-ingested sources. The mobile device's primary utility has shifted from fetching web data to ingesting personalized context. Transferring that ingested data from an edge device to a central processing hub requires a seamless synchronization layer. Phase 3 manages this through the unified engine. The sync mechanism connects directly to the Gemini app's global navigation. Any notebook populated on mobile instantly appears in the navigation across all your other devices. This establishes immediate data state parity between the app and the web interface. The system maintains a shared context window across disparate hardware ecosystems, ensuring data is ready for synthesis regardless of where it was captured. This automates the invisible handoff of semantic context between the mobile field and the desktop hub. That context arrives at the final stage of the pipeline, web-side execution. This ecosystem utilizes asymmetric compute. Mobile hardware manages the lightweight ingestion, while the web environment performs the heavy synthesis. Opening NotebookLM on a browser allows you to continue projects started on your phone. One specific tool available in this environment is video overviews. These videos are generated using the tailored PDF and chat sources captured back in the ingestion phase. The web integration also supports the creation of slide decks. Creating a full presentation relies on the synchronized context window built from those mobile notes. Generating a slide deck requires significant compute power compared to the initial mobile upload. The system allows you to transition from a field document upload to a structured presentation without any manual file transfers. The environment reserves high compute tasks for the web while streamlining the ingestion of source material. Viewing the full architectural model, we can trace the entire journey from mobile input to web synthesis. This creates a continuous, cyclical knowledge loop. Localized mobile capture now feeds directly and automatically into high-compute web synthesis. This pipeline is available globally on iOS and Android at the free tier. Previously, these notebook features were limited to paid subscribers. Deploying this across the global free tier allows users to manage complex data structures across millions of mobile devices. Unifying the context window across hardware removes the technical friction from the edge-to-cloud knowledge pipeline. Today, the mobile device is much more than a phone. It is now a persistent sensory edge. Imagine a highly structured vault of personal knowledge. Until recently, extracting value required friction. You had to be at a specific desk, paying a toll. This animated diagram maps out the baseline state of Google's advanced AI capabilities, strictly prior to April 30th, 2026. On the y-axis, we have the access level, from free to premium. On the x-axis, the environment, from mobile to web. NotebookLM sits firmly in the top right, premium and web only. Personal knowledge management capabilities were strictly gated to Ultra, Pro, or Plus subscriptions. Then, Google deployed Gemini notebooks to all mobile users globally, entirely free of charge. This update alters the structural logic of user access and data priority. Moving a retrieval system of this complexity from a paywall desktop interface into a free application actively rewrites how the system is used. It represents the global democratization of personal retrieval augmented generation, or RAG, architectures. It replaces the expectation of the desktop as workspace with a mobile-first reality. By simultaneously removing both the financial constraint and the hardware requirement, Google shifted the bottleneck of knowledge work. The limit is no longer system access. It is entirely determined by human ingestion speed. This global map visualizes the rollout's implications. Previously, the premium user base was a small cluster anchored in North America. By expanding to a free tier on native iOS and Android environments, the network multiplies exponentially, establishing heavy saturation across Europe. Entering the European market is a critical indicator of system maturity for any AI infrastructure. Supporting this density requires massive, simultaneous data processing capabilities deployed across highly decentralized server networks. Furthermore, satisfying strict regulatory frameworks in these territories necessitates a highly robust, secure data handling architecture operating silently in the background. By building hardware-agnostic integrations for both Apple and Android ecosystems, the deployment aims at total market saturation. Achieving scale simultaneously across pricing, hardware availability, and geographic footprint proves this is a finalized global infrastructure rollout, not a localized beta test. This split-screen visual illustrates the primary limitation of standard mobile AI interactions. They are inherently ephemeral. Standard zero-shot queries generate isolated answers. You ask a question, you get a response, and it is quickly lost as you scroll through the interface. To solve this transient memory problem, the update introduces an architectural bridge called Chat as Context. Mechanically, this allows users to transition previous conversational chats directly into specific named notebooks. Executing this transition forces the AI model to retain those specific conversational interactions as permanent, structured data points. The ephemeral chat is converted into a persistent node. This node now acts as a tailored context boundary for all future tasks related to that subject. The AI relies on these established bounds to evaluate subsequent queries, aggressively filtering out irrelevant data and reducing the probability of hallucinations. Executing this memory preservation strictly within the native mobile interface removes the friction of switching devices, a step critical for maintaining user retention. Chat as Context rewrites mobile UX. It converts a passive, temporary query tool into an active, continuous knowledge-building engine. This isometric illustration tracks the shift toward the mobile device as the primary data ingestion pipeline. The file integration capability allows users to upload source documents and PDFs directly into a notebook, straight from the Gemini mobile app. Bypassing desktop ingestion entirely provides a massive systemic advantage. It enables users to generate highly tailored, source-grounded answers in the field, divorced from a traditional workstation. This localized ingestion is connected to the wider ecosystem through cross-platform sync. Notebooks created on a smartphone instantly populate within the Gemini web interface. The data flows in reverse as well. Complex information structured on the web is immediately accessible for precise querying on mobile. This bidirectional flow facilitates asymmetric escalation. Projects initialized under tight mobile constraints, such as quick voice chats and document uploads, are specifically designed to be escalated later. The endpoints of this escalation pathway rely on high-compute, web-exclusive advanced tools. Users can execute extremely heavy generative tasks, producing comprehensive video overviews or slide decks, relying entirely on the context gathered uniquely from their mobile ingestion. It bridges the lightweight, immediate input of the mobile device with the heavy processing output of the web environment. The smartphone is no longer a scaled-down desktop application. It acts as the critical sensory ingestion node for a centralized, heavy compute RAG workflow. The massive scale and rapid speed of this newly established global ecosystem require a fundamental reevaluation of modern personal computing. The April 2026 update executed two distinct operational shifts. First, it removed financial and geographic friction, deploying advanced tools to a global, free user base. Second, it achieved deep systemic integration, allowing data to flow seamlessly from a transient mobile chat into a structured notebook and escalate to heavy web processing. Together, these shifts produce the continuous context loop. This loop operates independently of specific hardware or financial barriers. The user's tailored context state remains unified and perfectly synchronized. The rigid boundaries distinguishing mobile work from desktop work have been effectively erased by the underlying cloud architecture of NotebookLM. Developers and strategists who continue to operate under the assumption that mobile AI is merely a light version of desktop capability will develop severe architectural blind spots. The massive Gemini mobile expansion now firmly establishes the smartphone as the primary intake node for a global knowledge ecosystem. It functions as the anchor for a persistent, personalized database.